If we detected a large object 1 or 2 months prior to collision, then there's nothing we can do about it.
Any one of these events, nuclear, biological, chemical, Earth changes, massive earthquakes, they all end up in one thing, and that is anarchy.
It's extremely difficult to discover planets. Yet modern astronomy has managed to identify over 1,000 planets around other stars.
We can always gather some information from the stars so that we can be prepared.
If we have to go underground to survive, we're only going to accommodate 6,000 people at this time. What is everybody else going to do?
We use telescopes to search for life within our galaxy and these exoplanets that we have been discovering.
And it's also great to know that I'm contributing to a larger task in a very humble way.
On the final chapter of this season's Children of the Stars, we explore what the future holds for our universe and for our lives. We meet the guardians of our planet who monitor the sky, searching for any danger that might threaten our existence in the coming decades. Will underground bunkers keep us safe from a catastrophe? What do children think about the future of our planet? What surprises and discoveries will the largest telescope ever built by mankind reveal? We visit an observatory in Spain devoted to tracking potential threats from objects from outer space. A future impact could spell an end to our civilization.
Let's see what we're up to tonight, since the sky's been surveyed quite a lot this month, hasn't it? My name is Jamie Noman, and I've devoted all of my effort, my work, and my life to detecting asteroids and near-Earth objects, usually from this place, the Sagra Observatory.
A ver si se fueran las nubes que hay. No sé. Ayer estuvimos por encima de la eclíptica, igual hoy nos conviene observar.
I think today we could watch from below to change things up. There are areas of the sky that we still have not surveyed this month, and perhaps we should look into those. One could say that this place is among the sites with the darkest skies in continental Europe, if we don't take into account the Canary Islands. We are located in the southeast of Spain, near the Mediterranean coast, relatively close to the meridian, where there is also an important astronomical center called Calar Alto. What we are searching for is near-Earth objects. In fact, most of them are very small stones with a diameter of 100, 130, or 330 feet and can be detected at distances of 3, 6, or 12 million miles. Given that their light is so weak, we need very dark skies for good contrast to be able to detect objects with such faint luminosity. The danger of near-Earth objects is measured by two aspects. One is obviously their size. The larger the size, the greater the danger. And the second aspect is our response time. In other words, a relatively small object could be detected 6 or 7 years prior to impact. That might give us enough time to send a probe to divert its path. If we detected a large object 1 or 2 months prior to collision, then there's nothing we can do about it. Our mission is part of the first line of work in the process of how near-Earth objects are detected, how to calculate their orbits, and eventually, how they can be diverted. We are involved in the whole process. In the beginning, we first try to detect them in the sky. We use optical telescopes for detection, which are a very specialized type of telescope. The other type of telescopes, used for astrophysics, which have magnifying lenses of a much larger size, cannot be used for this purpose. For us, this kind of telescope is almost like a dinosaur. That is, they are not agile enough, not quick enough to survey the number of degrees in the sky that we have to cover every night. Therefore, we need a type of telescope which, compared to photography, has a large angle span, allowing us to cover practically the entire sky in one night, taking many images. The telescopes are operated remotely from this room, but they can also be managed over the internet from any place that we happen to be in. That allows observers, many of us who work here at the observatory, to work from anywhere we are. We have to bear in mind that these kind of observations require a prompt response. Since we never know when we might detect an object, we have to be on the watch at all times. This requires us to input information in real time, so we never stop monitoring the skies regardless of where we are. That means that we could be on a train, a ship, or holiday, anywhere. This graph shows us the sky, which has been surveyed each night by different international teams. Every month, this graph starts completely blank. And once the moon disappears, all of the teams start looking for near-Earth objects in different areas of the sky. Our mission tonight, for example, is to pay close attention to these areas that have yet to be covered, since we have a higher possibility of finding a new object. Preference is given to this area that is represented as a line through here, which is within the plane of the solar system, where there are more chances to find asteroids and near-Earth objects. The main idea is to take images of the sky for a period of time, and afterwards take the same images in the same areas in order to compare them. Usually what happens is that stars do not move during the period when we are observing. Each one remains in its place. But any object that moves, because it is closer to Earth, can be seen moving like a dot within our range of sight. What we're seeing on the screen right now is similar to what we see in web pages, and how we know that we have detected a near-Earth object. These tiny squares are only a small piece of the original image where sometimes these red circles indicate the trajectory of near-Earth objects. This object is moving at such a high speed that while stars standing still in the same place and represent a single point, we can see that this object has moved up to here. And here it is also shifted. Not only that, but it has also left a trail. That means the object is moving very fast. It looks like we have really detected one, right? We can see it here and here. Here it looks like a small star, and here it looks like something else, I think. Right?
del año 2012,
On February 25th, 2012, we found an object which clearly looked like a near-Earth object. We reported this object to the Small Planet Center. Evidently, at this time, we had no idea whether it could really be an object that could come near the Earth or not. After 4 or 5 days, it seemed that its orbit was very similar to that of Earth, and it seemed that it was intended to have an extremely close proximity to Earth within a year. That means that in 2013, it would come within 160,000 miles of Earth. Now, 160,000 miles can seem like quite a distance in terms of a person's movement on the planet, but in terms of astronomy, it is extremely close. On day 14 of 2012, it was identified as a very large object. It was a crater of about half a mile, large enough to break through the atmosphere and produce considerable damage. Since we started keeping records of near-Earth objects, we have never seen a near-Earth object as large as this. On this animation, we can see what would be the orbit of the Moon. This small ring represents the location of geostationary satellites. And we can see how on February 15th, 2013, in just a fraction of time, how it started to come closer. Here we see the South Pole of Earth, and it came really very close. That is closer than our own satellites, and there was even a risk that it might have collided with one of them. Here we can see the moment of its closest proximity, which coincides with a dark zone, more or less the areas of Indonesia on the Indian Ocean, and then it headed towards the north. If on February 14th, 2012 it hadn't passed at a distance of 160,000 miles, but rather had impacted our planet, it could have gone through the atmosphere in seconds and would have produced a crater of almost a mile. A large amount of matter would have been ejected from the ground, and everything within a radius of 62 miles would have been completely destroyed. In other words, it could have completely destroyed a large city.
Since the telescopes in La Sagra are operated remotely, Jaime Neumann can be alerted of any new near-Earth objects wherever he may be, even while at sea.
We are sailing in my brother Miguel's boat. We go out a lot, all year round. During the summer, we enjoy sailing to the Baleares Islands, which are close by. They are beautiful. On February 23rd, 2012, we were bringing in the boat, after a night of sailing with my brother and some friends. And since it's part of my job to always stay connected to the portable computer, the tablet, watching how asteroids were being detected at La Sagra, and you know, it could have been here, on the boat, or from a train or an office or home. It just goes to prove how we must always be connected. Anytime that a near-Earth object is detected, it is always very exciting at first, since one knows very little about it. You can't really tell its distance. Around this time it was very exciting since we were having an evening of fun with friends. And then near sunrise, at the most unexpected time, we discovered that object. Working on this fills me in a very personal way, and it's also great to know that I'm contributing to a larger task in a very humble way. Our job is to prevent an extinction event for our species, or to prevent an impact over a city or at sea near the coast, since there would be a lot of damage to human lives. There is no doubt that I am a meteorite hunter. Sometimes a hunter, sometimes a fisherman, since both jobs are very similar in a way with the sky. But my job is very different from the other observations carried out in the world of astronomy. You always have to be on permanent alert, like in the trenches. Yes, we really are in the trenches, since we never know when an asteroid might approach the Earth. We have obstacles like the light of the moon or clouds that can make our work at night harder. So it is a strategic game, hunting them down and detecting them.
We travel to the United States to visit a private company that builds bunkers. These high-tech shelters are designed to resist any kind of catastrophe that could potentially ravage our planet.
For the last 5 years, we've been building shelters, as many as we can, as big as we can, and wherever we can, to accommodate as many people as we possibly can on the planet. Right now, we have enough shelters, either existing or under construction, for about 6,000 people, which is almost 1 in 1 million people. That's a lot of people, but it's not even scratching the surface, which makes you worry or wonder, what are the other 999,999 people on the planet going to do if indeed disaster or catastrophe strikes, to the extent that we cannot be on the surface. Any one of these events, nuclear, biological, chemical, asteroid, comet, earth changes, massive earthquakes, all of these types of events, they all end up with one thing, and that is anarchy, where there's no law, there's no order, because government itself is incapacitated by these mega events. If we have to go underground to survive in a shelter or a bunker, we're only going to accommodate 6,000 people at this time. What is everybody else going to do? So a solution that is turnkey, that includes everything you will need underground to survive for up to 1 year without going back to the surface, without going back to see what's going on, no worries, you're covered, you're protected, sealed in behind blast-proof doors, behind nuclear, biological, and chemical filtration, so pandemics and war gases, nothing will get in. And all the food that's necessary, and the clothing, and the toiletries, everything that you will need to survive for up to a year. Our newest shelter in Kansas, which we just started a month ago, it already exists. It's a giant underground limestone mine that it's not round or deep, it's flat. It's a half a mile long and a quarter mile wide. It's as big in square footage as the Empire State Building in New York City. It can accommodate 5,000 people with room to spare. It's just huge. The biggest private shelter on the planet. We're finishing up the interior of the shelter now, all of the improvements. But the most amazing thing is the cost. That we were able, because of its size and the way we're doing it, to cut the cost by 90%. This shelter, the cost per person is about $6,000. So we've lowered the cost by nearly 90%. There are events, such as, let's say we were talking about a asteroid or a comet that was going to definitely hit the Earth. Well, we know of one that's going to come very close. It's in the year 2029. So here we are sitting in 2013. So it's about, 18 years away? And this asteroid called Apophis, if it hit the Earth, would be an extinction level event like the dinosaurs. So as far as having notice, right now you have 18 years notice. Could you get to Kansas in 18 years? Sure you could. NASA's very concerned, the Russians are concerned, everybody's tracking that asteroid. The current belief is it's going to miss us by just a little bit. But then it comes back around in 2036, just a few years later, and then it's very close. We don't know what the aftermath of any event is going to be, including an asteroid. Okay? The dust could settle. To say that the Earth will be scorched, the atmosphere will be gone, and there's nothing to live for is the worst possible outcome. It's not the most probable outcome, it's the worst possible. The most probable is whatever happened will subside and we'll be able to come back to the surface and start again. Farming, creating society, and hopefully do it better than we did it the first time.
We journey to Bogotá, Colombia, in order to learn what children think about the future of our planet and the universe. Is it as catastrophic as Robert Vicino from the Vivos project envisions? What are their dreams and hopes for the upcoming decades?
Yo creo que sí, porque no se han descubierto demás planetas.
Since new planets have been discovered, I think there could be a chance that life exists on other planets.
En otros planetas.
Es imposible que en un universo que tiene.
I find it hard to believe that in a universe that's 1 billion light years old, that there's only one planet with living beings. I think there's more, and they probably have more advanced technology and higher intelligence.
Tienen tecnología mayor y inteligencia superior.
Yo sí creo.
I also think there's life somewhere else, but I don't think they look like extraterrestrial beings. They probably look like us, but more evolved.
Yo pienso que sí hay vida alienígena.
I think alien life does exist.
Físicamente yo creo que se verían como
I think their physical appearance is probably very strange. No, I don't think we're the only living beings in the whole universe. I think there's probably more diversity.
Yo creo que hay vida en Júpiter.
I think there is life on Jupiter, since I once heard that there was life there due to its great red spot.
Mancha roja. Yo quisiera ser astrónoma.
I would like to become an astronomer because I am very interested in the secrets that the stars might hold.
Me gustaría ser ingeniero.
I would like to become an aerospace engineer, like those from NASA. I am already an amateur astronomer. I like astronomy because the constellations can show us a large part of our history.
Gran parte en la historia.
Yo en verdad que quisiera.
I really would like to become an astronomer.
Me gusta mucho el espacio.
I am very keen on space.
Si llegara un día en que la Tierra se destruiría completamente.
If the Earth was completely destroyed, I would go to Mars and build something that allows us to live there.
Y yo haría como.
I would build a city with a giant dome so that the oxygen would remain inside.
Gigante para que el oxígeno siga ahí. Yo primero observaría Marte, buscaría.
I would observe Mars first. I would search for life and water there. I would search for the same things that we have here on Earth. Well, if a base camp was established on Mars, it should have enough oxygen for humans to breathe. It would require a large amount of food, so the people that are there can eat. People would have to get used to weather conditions. I think I would enjoy leaving the planet and traveling to other places. I might even see other types of animals. Someday the sun will stop shining, but we're a long way from that time. Right now, we should start caring for our planet because the ozone layer is becoming thin. Many animals and plants are already dying. If things continue to be the way they are now, in 50 years there will be no planetarium, nor Bogotá, nor Colombia, nor South America, nor anything in the world.
During Children of the Stars, we've discovered a rich tradition of stargazing throughout Mesoamerica. For centuries, the Mexicas and Maya followed the movement of the stars. Is the connection with the sky still alive today? What shape will these ancient traditions take in the future? In order to answer these questions, we go to San Pedro Martir, the most modern optical observatory in Mexico.
We're here at the National Astronomical Observatory. Inside the enclosure is a 6.5-foot telescope. From here, you get a view of the whole mountain range. What makes this place special is that you can see the forest, the desert, and the sea at the same time. This site was chosen for astronomical observation since it has many features that serve that purpose. First of all, it's far away from cities, so we have no light pollution. If you have light pollution, it would make matters more difficult, since the astronomical objects that we observe are already hard to see. For example, if you place a light bulb near your face, you won't be able to see what's behind it. In 2010, a law was passed in Ensenada with the purpose of protecting the sky from the light of nearby cities. This doesn't mean that the cities are required to switch off their lights, since that wouldn't be secure. What we're aiming for is making them more efficient, because we've found that some lights are not facing down, and almost 30% of the light goes up into the skies.
My name is Juan Echevarria, and I am a researcher at the Institute of Astronomy. I am usually here 5 days. That's usually my scheduled time to observe. This is the third night in a row that we have been observing a cataclysmic variable known as AH Hercules, which we expected to find at its faintest. It is a star with eruptions. Suddenly it becomes bright, and then less bright. We will continue to watch this star for 20 consecutive nights. But since I am 60 years old, I don't stay here observing for more than a week.
I am a resident astronomer at the observatory. Basically, we're in charge of supporting astronomers and calibrating the instruments they will use. Most important is the 5-meter telescope. We need to check out many things before nightfall. Usually 2 hours before the sunset, we have to test the telescope and its movements. We need to make sure that there are no obstructions around the telescope, so that it can move freely at night. With this telescope, we can observe several types of celestial objects. For instance, nearby stars, faraway stars, faint objects, galaxies, planetary nebula, reflected light nebula, and planets. This is a robotic telescope, which has the advantage of pointing quickly towards a particular area of the sky where any explosions are occurring.
This telescope is around 84 centimeters. The observatory has 3 main telescopes: the 2-meter, the 1.5 meter, and the 84 centimeter. There are more projects in progress, but these are the 3 main telescopes.
The
main advantage that we have in this observatory is the quality of the sky. Literature shows extensive studies of the quality of the sky from this site. The other unique feature of this site is the landscape, which is amazing, very beautiful. I am proud, not only as a university student, but also as a Mexican, to be able to work here, surrounded by this beautiful sky, by marvelous scenery, all this biodiversity, and the historical aspect that I am very proud of as a Mexican.
The Atacama Desert is yet another place with extraordinary conditions for observing the night sky. Here, the largest optical telescope in the world is under construction. It will yield amazing discoveries in the future, which will most likely revolutionize our concept of the cosmos.
We're a bit further south from the city of Antofagasta, in a unique site in our planet. If you look around you, it seems that there's no life of any kind. It looks like an uninhabited planet. We're in a very iconic place in Chile, since we are a few miles away from Cerro Paranal, home to the best telescopes in the world. We're also a few miles away from the future observatory of Cerro Armazones, where the largest astronomical telescope in the world will be built. It's currently in the planning and development stages. One of the main challenges for mankind is to be able to understand whether we are the only intelligent beings in this cosmic immensity, or even the only living beings that inhabit a huge universe, where there are billions of stars in each galaxy and billions of galaxies as well. It's very hard to detect planets. Nevertheless, astronomers have currently managed to identify over 1,000 planets surrounding other stars. But the future telescopes that will be built on that hill will provide information on what kind of planets they are, including whether these planets could hold any type of life. If one looked at thousands and thousands of places and never found any with any trace of life, well, I think that would pose a terrible weight on us. If indeed we are the only living beings in the universe, we should take all the necessary precautions. So I think there are enormous challenges ahead, and of course, astronomers have a role to play. But these are challenges for mankind, not only for astronomy. We're not speaking about the last quasar, which might not interest the public. We're talking about mankind. We're 24 miles away from the site, which 10 years from now will be the home to the largest observatory in the world. A 130-foot telescope will be built on the summit of Cerro Armazones. Up to now, the technology has been partially tested, to some degree. But with a telescope of that size, we're really pushing the limits of modern technology. Well, this is the first time that I've visited Cerro Armazones. It's amazing to think that we're only 12 miles away from what is currently the largest facility for astronomy in the world, the Cerro Parañal. But on the other hand, this is the future. We're walking on the grounds that will be the future of astronomy for the next 50 years.
I'd never been in Cerro Armazones before. The place is different from any other that I know. The road was very uneven since a proper road has not yet been built. A good road will be mandatory in order to bring in the mirrors of the super telescope, which will be built on the site. This is an unforgettable experience. Seeing this place before the summit of the mountains gets blasted off and before the giant telescope is built, it is amazing. I hope I can remain active for another 20 years so that I can take advantage of that amazing telescope.
Well, this is like a tower to measure the quality of the sky. It's known as a STIM and has been used in almost all observatories, like Tololo, La Silla, Las Campanas, as well as here. This was the first one installed. The telescope that will be built on Cerro Armazones is truly a telescope of the future. Astronomers already reached the limit. We can't build one-piece mirrors with a diameter larger than 26 feet. In order to build a 130 feet or 137-foot telescope, 1,000 hexagonal segments need to be made. I mean segment-like tiles, where each one is supported at 3 points. They'll form a parabolic surface or a spherical surface, which will be 137 feet in diameter. These are here, installed on good ground.
Do you know that they get full of dust and the Martian soil cleans the dust off? That is how they continue to operate.
Oh, imagine that.
In very simple words, the importance of a giant telescope is that it will allow us to classify planets. With current telescopes like the VLT, for instance, or telescopes in La Silla, we are discovering planets. This giant telescope will allow us to classify those planets, to learn whether they have an atmosphere, what type of atmosphere, measure their size properly. Well, it is very difficult to tell whether life exists in the universe. We use telescopes, which are the tools for astronomers, in order to search for life within our galaxy, for example, in exoplanets that we have been discovering. One step further is to ask whether any intelligent civilizations can exist. That idea is a matter of speculation, and the answer is that we do not know, and we will not know for years to come. I am optimistic. I think we are at a historic moment for humanity. We are on the verge of discovering other planets similar to Earth, while we try to find any other type of life in the universe.
So, to start, building such enormous telescopes poses a technological challenge. It requires developing new ways to make it work. In a few more years, it'll be available for all of us to use. Remember the space race of the 60s? It seemed impossible to take man to the moon. It wasn't feasible with the technology available in the 60s. New technology had to be developed, and currently, we are all still using that technology. Therefore, simply by posing new challenges, humanity can reap enormous benefits. Perhaps the challenge of building a 130-foot telescope will result in our children and grandchildren having new types of things or goods which they would not have otherwise. So I believe that the whole human adventure is wonderful.
Another possible future adventure is to facilitate human space travel and to build new homes outside of planet Earth. To investigate this possibility, we meet Pedro Duque, an experienced Spanish astronaut.
Dentro del trabajo de astronauta he hecho varias veces.
As an astronaut, I've been involved as a backup here on Earth. And I have also taken part in 2 space flights. The first was in 1998 with an American shuttle, which involved a whole series of experiments we had to carry out. I was also one of the flight engineers in the shuttle. The second time I was on the International Space Station for 10 days and on board of a Soyuz spacecraft carrying out experiments. I was the co-pilot in the Soyuz spacecraft. There are people living in the space station permanently now. We have a crew of 6 people. The day is scheduled hour by hour. We have 24-hour schedule, like other normal people. The working day is fixed by the control centers in the different countries. All astronauts must exercise regularly. When you are on the space station for a long time, you must exercise during an hour and a half besides your work routine. That is how we get organized, more or less. We carry out experiments of various types within several scientific fields. We have medical experiments on which I was involved related to the cardiovascular system. I had to wear electrodes on the heart. Others are related to the response of the brain. So one must also have electrodes on the head, and well, other tests from other fields as well. In theory, we understand how we could explore Mars with astronauts. Only in theory. We need to develop the equipment and the technology required, as well as systems, backup systems, which would enable autonomous life for astronauts on such a trip. But we more or less know how it could be achieved. I think that space exploration, taking people to different places of the solar system, as far away as possible, and for them to return and tell their story, to do research in those places will happen eventually. Because human nature does not remain static. It will happen whenever it is feasible. So I think the only relevant decision from the various governments on Earth is, do you want to be part of this adventure or not? Latin America has a role to play because the relationship in terms of the technological capacity and economic capacity in human society changes throughout history. Everyone remembers that when there was more wealth in Latin America, they would support Spain. And at other times, it has been the other way around. These things change, and Latin American governments should promote these projects so that there is a basis for this to happen. Education is extremely important, and to provide support to enterprises with projects so that the engineers can work and develop.
Andrés, y junto con Ed, que me está filmando ahora, y Yuri Malenchenko, pues esperamos tener una buena bajada.
Yo tengo hijos y claro, esas cosas las he pensado.
I have children, and of course, I've thought about these questions before. I think the main message to convey to children and young people is that knowledge is a great source of fun. For instance, if you visit the Museum of El Prado and you don't know anything about the artists who did the paintings, you might not enjoy them to the fullest.
No sabe quiénes son los pintores y no sabe quién vino antes de quién, se divierte muchísimo menos. Es el conocimiento es lo que le hace divertir.
Knowledge is what makes things enjoyable. So the more you know, the better. So that enjoyment and enthusiasm is what results in innovation, and that is what we are looking for.
Esta nave se irá y se quemará en la atmósfera. Y con eso acabamos. Hasta luego, amiguitos.
In the same way that astronaut Pedro Duque wants to convey a passion for learning to his children, we meet another father and son in an entirely different environment. In the Mayan jungle of La Condona in Mexico, we will witness how, in the 21st century, indigenous communities are trying to find a place within our high-tech world, conveying their ancestral knowledge to new generations so that their legacy is not lost in the future.
We are in the Bonampak archaeological area. My son is coming along too. His name is Yuk in the Mayan language, but he is also called Damien, like myself. Here, as Lacandonan people, we are trying to maintain our history, our roots. In this case, I was telling my son about our surroundings in the Lacandan jungle, about nature, about where we are heading, in our own language, which is Maya Lacandonan. We are going to an archaeological site, which is the home of our ancestors.
Bonampak is a Maya word meaning wall paintings. The walls of this imposing archaeological site are richly decorated with stories, myths, and legends that transport us back hundreds of years.
We are in the Temple of the Paintings, built in 790 AD. This could be one of the last monuments built in this Mayan city by the last ruler, who was known as Chanmuan II. There are 3 individual rooms. Each room is small. As we enter the rooms, we can see the depicted scene. When we enter and look at the paintings, it seems that they become alive again, as during the Mayan time. In this case, in this room, the scene represents a party. The party revolves around presenting a boy, who is the heir to the Bonampak throne. Our ancestors, the Maya, have left us a wide legacy of knowledge, which still remains after centuries. Some has been lost. So it is also a question of whether you really have the intention of learning. We still watch the sky. At daytime, we watch natural phenomena. For instance, when is the season of rain approaching? When is a good time for sowing and planting? At night, it's the same, the stars. We can always gather some information from the stars so that we can be prepared. Their beliefs, their views, what they thought, how they imagine that time elapses. We could forget all that, but we would also lose our roots. And on the other hand, that would also mean destroying part of our own nature. So to look at the past can become very valuable over time. We might remember something and use it as a way to move forward.